Hello everyone and welcome back to Study Room. I hope you have revised all the concepts from the previous classes. So let's get started. So today we'll be studying about equation of motions by graphical method. Okay. So why do we have to learn about equations of motion? This is the foremost question which comes in your mind, right? So it is to be able to answer the questions in our daily lives, like how long it will take to go from one place to another, how fast a car was moving when it hit a tree, how long it will take a falling object to reach the ground. You can think of anything. If you want to calculate some distance, if you want to know the time your ball will just fall, you can know many things with the help of equations of motion. So it is very useful, right? It is very useful. So we'll be happy in learning about it. So 3 equations of motion. When an object moves along a straight line with uniform acceleration, it is possible to relate its velocity, acceleration during motion and the distance covered by it in a certain time interval by a set of equations known as equations of motions. Okay, so it is basically the relation, right? The relation we give to velocity, acceleration and distance, right? So we can relate them with the help of three equations of motions. Okay, we have 3 equations of motion. So what are they? So first is velocity time relation, that is your v is equals to u plus at. Then is your position time relation, where your position is related with time, that is your s is equals to ut plus half at square. Then third is your position and velocity relation, that is a relation between s and your velocities, right? So it is 2as is equals to v square minus u square. So we derive this third equation by eliminating t in the second equation and putting it in the first equation. We get the third equation with the help of first and second equation. So don't worry, we'll learn more about it, that how did they come. We'll learn about it graphically in the further part, right? So for as of now, just see this: v is equals to u plus at, s is equals to ut plus half at square, and 2as is equals to v square minus u square. So as you know, v was your final velocity, u initial velocity, a acceleration and t time, s was your displacement, right? So these were all the things we were talking about. So let's look at this. Consider the velocity time graph of an object that moves under uniform acceleration. What does that mean? Uniform acceleration means, what does that mean? Does that mean constant velocity or does that mean uniform velocity? You tell me. Uniform acceleration. See, constant velocity means that your velocity is not changing, but acceleration means that your velocity is changing. So it does not mean constant velocity. Uniform acceleration means that your velocity is changing uniformly. Okay. Okay, so just like in this case, your initial velocity is u and your final velocity is v. Okay. So, okay. And your time taken from here to here, from origin, from your like the time you started till the time t, the total time taken is t, right? So your initial velocity is u and final velocity is v. Okay. So moving ahead, we'll know about velocity time relation. So observe the initial velocity of the object is u and final velocity is v, and the velocity changes at a uniform rate ac. So now with time, as you can see, it is a straight line graph, it is a linear graph. That means your velocity change is constant throughout, right? Velocity change, not velocity but velocity change, okay? So it is constant throughout. In the case of uniform acceleration, it is accelerating, your velocity is increasing with time, okay? But in equal amounts in equal intervals of time, okay? So the perpendicular line BC and BE are drawn from point B on the time and the velocity axis are like respectively. Your initial velocity is represented by OA and your final velocity is, see, your initial velocity is represented by OA and your final velocity is represented by whole, right? From, we can say this as O, right? as OB, right? If we measure from here, this whole distance is V, this is U. If we have to calculate BD, what it will be? It will be BO minus CD. And what is it? Whole V minus U. So if we have to find the value of BD, it will be V minus U. Okay. Similarly, if we talk from here to here, this distance is T because origin to T. Okay. So we can calculate the area of this triangle like this, right? So this is how it's explained, right? Right, V minus U, BD. Exactly. So acceleration is your change in velocity upon time taken. You can see it in this also. See, I'll explain this graphically. So the slope of this velocity time graph gives you acceleration, right? This is your acceleration A. So what it is your V minus U by T, right? Acceleration. Using this triangle also, right? So this is, we can just calculate acceleration graphically also. Change in velocity upon time taken. We see that our BD is our change in velocity, that is V minus U, and what is our time? T. Okay. So as we know that A is equals to V minus U by T. We got this graphically because acceleration is a slope, right? It is your and it comes out to be V minus U by T, change in velocity upon time taken. From here, what do we get? We send T to the left side, we get AT is equals to V minus U, which implies we get V is equals to U plus AT, and that is our first equation of motion. Okay. So see, we derived this graphically. So now we will be talking about position time relation. What was that? S is equals to UT plus half AT square. So now we will be deriving this, and we know that, you know, area under this velocity time graph gives displacement, right? So the slope was giving us acceleration. So when we wanted to derive acceleration relation like V is equals to U plus AT, we considered the slope. But when we have to derive the displacement, we will consider the area under curve, right? Area under VT graph. Okay. So look here, if you have to so this is your initial velocity, this will be your final velocity, right? After time t, your final velocity is v. Okay. So now if you have to calculate the area, like you have to find the displacement, right? So what will be the displacement? You have two methods to calculate this. Either you can add the area of triangle plus area of rectangle, or you can simply find the area of trapezium. Do you remember the formula of area of trapezium? If not, then do revise. It is area of trapezium is equals to half into sum of parallel sides into height. Okay. So what is your parallel sides? OA and BC are parallel, and what are they? OA is your U and your whole BC is V, right? Because at this point your velocity is V, so this whole will be V. So what will be area of trapezium? Half into U plus V into height. And what is your height? Height is your time. Okay. So half into U plus V into T. You get the area of trapezium. Directly you will get the displacement. Also, what you can do is you can add the area of triangle plus area of rectangle. What it will be? Half into base into height, right? What is your base? T. And what is your this height? BD. It is your V minus U. Because whole BC is V and DC is U, then BD is V minus U. Plus, what you can do? Area of rectangle. What is your area of rectangle? Base, length into breadth. Okay. So what is your length? It is your T into breadth U. Right. So you can calculate the area of displacement in both the ways. Okay. If we talk graphically. So this is how it is explained, right? The same thing which I told you. Area of rectangle plus area of triangle, right? If you have to find the area of OABC. So you have both the methods to do. Either you can add the area of rectangle and area of triangle, or you can directly find the area of trapezium, okay, by the formula. So by substituting, you get this. Your equation S is equals to UT plus half AT square. Try this on your own. It is very simple, as I have explained. Do write and try, okay. So this is your second equation of motion. So now position velocity relation. Again, now we will be finding the area of trapezium, as I told you. When we had to find the previous relation s is equals to ut plus half at square, in that case, what did we do? We find the area of triangle and area of rectangle and we added them, right? So, one more way to find the displacement is to find the area of trapezium, as I told you, right? So, what can you do? You will directly find the area of trapezium, the same thing I told you, like this. We derived it in the previous slides. So, you get this relation and we get this relation 2as is equals to v square minus u square, and this is your third equation of motion, okay? So, what are the three equations of motion? Let's revise them and do derive them in your notebooks, okay? So, first is v is equals to u plus at. This is just first equation. Second is your s is equals to ut plus half at square. And third is your 2as is equals to v square minus u square. Also, again, I am just denoting this, okay? 1 second. So, again, let us revise. V was our final velocity, u was our initial velocity, a was acceleration and t is time. So, similarly, when we talk about the second relation, so S is your displacement and u is your initial velocity, t is your time, a is your acceleration. In the third relation, again, acceleration as displacement, v final velocity, u initial velocity. So, do remember all this. So, now let's do some problems on equations. So, we'll use these three equations of motion to solve some questions and you will definitely get confidence. Just remember these three equations, okay? So, our first question. So, let's solve it together. Starting from a stationary position, if we are talking about stationary position, this means that we are starting from rest, right? So, Rahul paddles his bicycle to attain a velocity of 6 meter per second. His final velocity is 6 meter per second, his v, okay? In 30 seconds. Time is your 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meter per second. In next 5 seconds, calculate the acceleration of the bicycle in both the cases. So, what is our case 1? So, our case 1 is when our object was stationary. Okay, so our Rahul paddles the bicycle to attain a velocity of 6 meter per second, correct? So, our final velocity becomes 6 meter per second and the time is 30 seconds, right? So, what is our acceleration? Acceleration we have to find in the first case. We know that v is equals to u plus at, which implies a is equals to v minus u by t, right? So, what is our v? Our v is 6, u 0, t 30. So, our acceleration is 6 by 30 and that is 1 by 5 and it is equals to 0.2 meter per second square. This is your case 1. What is your case 2? Your case 2 is that now he applies brakes, right? So, if he applies brakes, so now his initial velocity was 6 meter per second, right? And now he applies brakes such that the velocity comes down to 4 meter per second in next 5 seconds. So, now he applies brakes and the velocity comes down to 4 meter per second. His final velocity becomes 4 meter per second when in next 5 seconds, okay? In next 5 seconds. So, again calculate the acceleration. What will be the acceleration? V minus u by t. 4 minus 6 by 5, that is a minus 2 by 5 is equals to minus 0.4 meter per second square. Don't forget the units. Also, you can see since the acceleration is negative, what does that mean? That your velocity is decreasing with time, right? So, you can see, and it should decrease because we are applying brake. That means that we want to minimize the speed, right? Minimize the velocity. So, this is how we can do this. Next question. A car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds, okay? So, initial velocity was 18 km per hour and your final velocity is 36 km per hour. So, can we convert it into meter per second? Of course, we know that as I have explained earlier also, 1 kilometer is 1000 meters and 1 hour is equals to 3600 seconds, right? So, the factor here is 5 by 18. So whenever we want to convert kilometer per hour into meter per second, we multiply it by 5 by 18. So 18 into 5 by 18 is equals to 5 meter per second. Similarly, our final velocity is 36 into 5 by 18, that is your 10 meter per second, okay. So firstly, we have to calculate the acceleration. What is your acceleration? It is your v, my change in velocity upon time taken, right? What is your change in velocity? 10 minus 5 upon time is 5 seconds. So here your velocity, acceleration comes out to be 5 by 5, that is your 1 meter per second square is your acceleration. Second, what is the distance covered by the car in that time? So you can apply any of the equations. Either you can find the distance by s is equals to ut plus half at square, because you have to calculate s now, right? Or you can also use the third equation of the motion, that is 2as is equals to v square minus u square. Which one do you want me to use? Do tell. Okay, so I'll calculate the distance through both the equations, okay? So firstly through this. So your s is equals to ut, 5 into time is your 5, plus half at square, again 5, right? This is your 25 plus 25 by 2. This comes to be 25 plus 12.5, and this is your how much? 37.5 meters, right? So let's calculate the distance through this. From this equation, your s is equals to v square minus u square upon 2a, right? So what is your v square? V square is your 10 square. 10 square minus 5 square upon 2a, right, is equals to 100 minus 25 upon 2, right, is equals to 75 upon 2, that is your 37.5 meters. So as you can see, you can calculate the distance from both the formulas, okay. So whichever you like, you can use that formula, okay. So you should know both. So let's do this question. The brakes applied to a car produce an acceleration of 6 meter per second square in the opposite direction to the motion. If your acceleration is in the opposite direction to the motion, what does that mean? This means that your acceleration is negative, okay. Okay, so the brakes are applied, okay. If the car takes 2 seconds to stop, if the car is stopping, what will be its final velocity? That will be 0. Of course, if it is stopping, right? And your time is 2 seconds given, and calculate the distance. You have to find the s is equals to this. So we don't have any equation of s in which we don't have u, right? So we need u. For calculating s, we need u. In s is equals to ut plus half at square also we need u. In 2as is equals to v square minus u square also we need u. So firstly, we'll calculate u. How can we calculate it? Through first equation of motion. As we know, v is equals to u plus at. So 0 is equals to u plus minus 6 into t. What is your t? 2. Which implies u is equals to 12 meter per second. So now we got the initial velocity. Now we can calculate the distance from any of the equations. So let's use s is equals to ut plus half at square. So is equals to 12 into t plus half minus 6 into, don't forget the minus signs. Your acceleration is negative because it is in the opposite direction, into 3 square, right? So what is this? Is equals to 24 minus 12, that is your 12 meters is your distance travelled, okay. So let's do another question. A bus starting from rest moves with uniform acceleration of 0.1 meter per second square. So bus is starting from rest. What was its initial velocity? 0, because it is starting from rest, no? So its speed must be 0, right? Moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. T is your 2 minutes. So let's convert this into seconds. Don't directly use 2 minutes, okay? Because we have to use time in seconds. So what is your 2 minutes? It is your 120 seconds, because 1 minute is 60 seconds. So firstly, we have to find the speed required. Firstly, we have to find v, right? So how can we find v? Simply v is equals to u plus at, right? So is equals to 0 plus 0.1 into 120. What is it? Is equals to 12 meter per second. Secondly, we have to calculate the distance traveled. So see, your three equations of motion are so useful. You can calculate anything, right? So S is equals to ut plus half at square is equals to, what is a u? 0, right? 0 into t plus half at square into 0.1 into t square. What is your t? 120 square, right? Is equals to 0.1 into 14400 upon 2, right? Because 12 square is 144 and 00, right? And then we'll just calculate this. And this is, there is 1 into 0.1, right? So 720 meters is your distance traveled. Isn't that simple? Next question. A train is traveling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. Okay. So our initial velocity is 90 km per hour. So let's quickly convert it into meter per second. 25 meter per second. So now your acceleration is in negative direction. Your velocity is of course decreasing. Also you have applied brakes, right? So find how far the train will go before it is brought to rest. If it is brought to rest, then your final velocity will become 0. What are you supposed to find? Nothing but S. So here, see, since we don't have time, so we can't use the second equation of motion. So, but we have one equation where we have the relation between position and velocity. Which equation is that? 2as is equals to v square minus u square. So, we can directly use this. Or else, if you want to use the second equation of motion, you want t, right? So, for that, you have to first use v is equal to u plus at to calculate t. Then use second equation. So, it will be a lengthy process, right? So, we will directly use third equation of motion. So, what it is? 2 into minus 0.5 into s is equals to v square, that is your 0 square, minus u square, that is your 25 square, right? So, it will be minus 2 into 0.5 is 1, right? Minus s is equals to minus 625, which implies s is equals to 625 meters. So, see, how far will the train go before it is brought to rest? 625 meters. See, you can calculate the distance of train also, like how far it will go and everything. Isn't that interesting? Next question. Again, very easy. A trolley while going down an inclined plane has an acceleration of 2 cm per second square. Acceleration is your 2 cm per second square. So now one very important thing in this question is that it is given in centimeter per second square. Okay. So you all should know this. 1 meter is 100 centimeters. So 1 centimeter is 0.01 meters. So what is 2 centimeter? 2 centimeter is 0.02 meters, right? If in case you want to calculate in meter per second square, so you must know this conversion. Otherwise, you can directly calculate in centimeter per second. So, we will do both, okay. What will be its velocity 3 seconds after the start? If it is starting, initial velocity is 0. Time is your 3 seconds. Nothing, you have to just calculate v is equals to u plus at. You just have to calculate the final velocity from 3 seconds, right? So, what will it be? 0 plus 2 into 3. That is your 6 centimeter per second square, or you can also say, since 6 centimeter is 0.06 meter, it will be, so 0.06 meter per second square. Both are correct in meter per second square and in centimeter per second square. Let's do question 4. A racing car has a uniform acceleration of 4 meter per second square. Okay, a racing car has a uniform acceleration of this much. What distance will it cover in 10 seconds after start? Again, we are starting. If we are starting, our initial velocity will be 0. Time is given to us as 10 seconds. What are we supposed to calculate? Distance. We can directly use s is equals to ut plus half at square, right? U into t, 0, plus half into 4 into t square, 100. So, this is your 200 meters. Isn't that simple? If you want to use the third equation of motion, for that, what do you need? You need v. So, first you have to calculate v through first equation and then you will apply third equation. So, it's better that you directly use the second equation. You have to do this smart work, okay, which equation to use. So question 5, a stone is thrown in vertically upward direction, okay, with a velocity of 5 meter per second. So our initial velocity is 5 meter per second. If the acceleration of the stone during its motion is 10 meter per second square in the downward direction. So your acceleration is in the downward direction. So you are seeing your motion is in this direction, your acceleration is in negative direction, right? So acceleration should be minus 10 meter per second square, right? What will be the height attained by the stone? We have to tell the height attained. So it will be nothing but the displacement covered by the stone, right? So we have to calculate the S, right? What will be the height attained by the stone and how much time will it take to reach there? So we have to calculate S as well as T, right? So one thing you have to notice in this is that whenever you, you are throwing something vertically upward, there will be a point when it will attain the maximum height, and that at that point your final velocity will be 0, because think of it, if your final velocity is 0, then only your maximum height is attained. No, because after your final velocity is 0, it will come again, right? If your speed becomes 0, your stone will come down again, right? So at the maximum height, your final velocity must be 0. So very simple, we have V, U, A. Can we calculate T? Yes. Which equation of motion are we supposed to use? First equation of motion. V is equals to U plus AT, which implies your V is 0 is equals to U 5 minus 10, because minus 10 into T, which implies 5 is equals to 10T, which implies your T is equals to 5 by 10, that is your 1 by 2, that is your 0.5 seconds. Isn't that simple? Very simple, right? You just have to apply the equations of motion. So next part, what will be the height attained? Simply, which equation will we apply? S is equals to ut plus half at square, right? So S is equals to u into t, 5t, and what is your t? We just found out 0.5. Acha, you can, alright, you can also directly use the third equation of motion. It will be smarter because you already have some things in the question, and you can directly use your third equation. So you can directly apply your third equation of motion here, right? 2as is equals to v square minus u square, because all the information given in the question. For example, if your time you calculate wrong, then your that will be wrong, you use the equation, and your time you calculate, right? So let's third equation, that is 2as equals to minus u square. 2 into minus into s, as you find out, is equal to square. So 2 minus 10 into s, you have to find out 0 square minus u square, that is 25, 5 square, right? Which implies minus 20s is equals to 25, which implies minus 25, right? S is equals to 25 by 20, that is your 5 by 4, that is your, how much? 4 ones are 4 and 1.25 meters, okay? So this is how you can calculate. So now we will be studying one very interesting and new concept, that is your circular motion. As the name suggests, it is dealing with circles, right? Yes, motion in a circular patterns, in a circle, right? So let's study about this. So what can you see in the video? So you might have heard your elders, using tape recorders which had that circular thing, right? And gramophones. So these all are working on circular motion, okay? All of these are working on circular motion. So it is interesting to know about this, okay? So motion due to change in direction of an object. So one very special thing about circular motion is, I don't know if you all have observed this, but let's discuss. So what do you say? What is a velocity? So velocity has two components, right? Magnitude as well as direction, right? So circular motion is that kind of motion in which you can have same magnitude, but your velocity can change every moment. Why? Because your direction is changing every moment, right? In a circular motion, you'd go here, then you go here, then you go here, then you go here, right? So your direction is changing at every instant. So circular motion is a motion in which your velocity is changing every moment, okay? Right. We say that object is, when the velocity of an object changes, we say that the object is accelerating, right? So then this is your accelerated motion, right? So the change in velocity could be due to the change in its magnitude or the direction, right? We have two components for velocity. It is a vector quantity, magnitude and direction. If magnitude changes, if only magnitude changes, then also velocity changes. If only direction changes, then also velocity changes. What does that mean? This means that since our direction is changing every moment, so it is an accelerated motion. So can you think of an example when an object does not change its magnitude but only its direction of motion? Yes, we can think. We just know it is circular motion, right? So we can have the same numerical value of the velocity. For example, a person or a particle is moving at 5 meters per second in this circle, okay? So even when its magnitude is constant magnitude, right? I'm saying that he is moving with the same 5 meters per second here also in the whole circle. But his direction is changing every moment, right? He's going here, then here, and we know that velocity has two components. Even if only direction changes, then also velocity is changing, okay? So what does that mean? That, can we think of an example? That is a circular motion. So motion of an athlete along a closed path, okay? So consider an athlete along different tracks as shown below. So note the number of times the athlete have to change his direction of motion while he completes one round. So let's discuss this together, okay? So we'll note the number of times the athlete have to change the direction, okay? So in this rectangular track, if the athlete starts from here, how many times will he change the direction? First time, second time, third time, fourth time. So in a rectangular track, the athlete has to change his direction 4 times, okay? And in this hexagonal track, he'll be changing it 6 times, right? His direction. In an octagonal track, he'll be 8 sides. He'll be changing his direction 8 times. So if we keep on increasing our sides, what will happen? We keep on increasing our sides. Then what will happen? It will eventually approach a circle, right? And what does that mean? That if we keep on increasing the number of sides, then the number of turns for the athlete will keep on increasing. So it will indefinitely approach a circle, like infinitely if we are increasing sides, right? So it will approach a circular position. And okay, we didn't discuss this. So how many turns are there in a circular path? Think about this. Can we count any number of turns? No. We can just see that in a circular motion or in a circular path, it is going in tangential direction. I'll explain the tangent to you 1 second. So this is your circle, right? So as in a rectangle, we could see 4 turns, but we cannot see, and in different figures, but we cannot see any turns in this circle, right? But we'll see that there are turns like in every point, right? We can draw tangent. What is tangent? What is tangent? If we consider a radius, okay, so a line which is drawn perpendicular to the radius is your tangent, okay. We have infinite radius, right? We don't have any fixed number. We have infinite radius in any circle, right? So at every point we can draw tangent, right? In every direction. As our object is moving here, we can draw tangent here. Object is moving here. So for circular motion, we have a tangential approach to see the number of turns and everything, right? So you can see in circle, we don't have definite number of turns. We have infinite turns, right? So circular motion. If the object moves with a velocity of constant magnitude along the circular path, the only change in its velocity is due to its change in direction of motion, right? The motion of the athlete moving along a circular path is therefore an example of accelerated motion. Why acceleration? Because velocity is changing every moment in a circular motion, right? It is changing every moment. Even when the magnitude is same, direction is changing, right? And we know velocity has 2 things, magnitude and direction. Even if only one of them changes, the velocity changes, right? So this is a ride which is an application of circular motion. So what is a uniform circular motion? So in this, when an object moves in a circular path with uniform speed, we're talking about speed. That means we're not talking about direction here, right? Only magnitude. So simply, what is uniform circular motion? If our magnitude is same, and direction will always change in circular motion, right? So direction is changing. So this is your uniform circular motion, okay? In your circular motion, you can also have, where your magnitude is not same. Magnitude is also changing and direction is also changing. Then it will be non-uniform. So what is a uniform circular motion? In which you have uniform speed. That means your magnitude is same. Speed, so we are talking only about magnitude. It is a uniform circular motion. So velocity is given by distance upon time. So what is the distance in a circular motion? It is simply the circumference of circle, right? And what is the circumference? It is 2 pi r. So your velocity turns out to be 2 pi r by t, okay? So one brainstorming question. Have you ever imagined what would happen to the motion of the planets if the sun disappears suddenly? Think about this. So your sun is like all your planets are revolving around sun, right? So what would happen if the sun disappears? Simply your planets will start to go tangentially, right? If there is no circular motion taking place, they will deviate from their path and they will go in a tangential direction, right? We studied about tangential direction, right? That from radius, it is the perpendicular, it is the line which is perpendicular to the radius at any instant, right? So planets will deviate from their original path, right? So tangential path taken by a body in uniform circular motion. So planets would start to move in a tangential direction to their path of revolution, right? In the tangential direction, as I told you, perpendicular to the radius of the circle at any point. So tangential path taken by a body in uniform circular motion. Once the sun disappears, there is nothing to attract the planet and they are released, right? Sun was the force which was controlling the planets, right? And they were moving in the circular motion. But if the sun disappears, if the sun disappears, then planets will not move in circular motion anymore. They will be following a tangential approach. For example, this is one planet, so it will go in a tangential direction. Tangential direction, right? Perpendicular to the radius. So they will be going in a tangential direction. This shows that direction of motion changed at every point when the planets were moving along the circular path, right? So what does that mean? So this experiment was done, or we can say that this thing shows, this observation shows, we can't say it experiment, we can say it observation, right? So this observation shows that our planets were moving along the circular path and the direction of motion was changing every instant, right? That's why we get this circular motion. The same principle applies for a stone tied to a string and rotated in a circular motion. So let's do a quick revision of everything we have studied in this video. Firstly, we did some numericals on 3 equations of motions, and what are they? V is equals to u plus at, s is equals to ut plus half at square, and 2as is equals to v square minus u square. Do solve questions and numericals, and I'm sure you'll enjoy them. If something is stopping or starting from rest, if something is starting from rest, your initial velocity is 0. If you're stopping, your final velocity has to be 0, right? These are some quick things. Then we studied about circular motion. We also derived these equations by graphical methods, right? And circular motion, and we got to know that in circular motion is a kind of motion in which our magnitude can be same or different, but your direction is changing, or different, but your direction is changing every moment, okay? So this was a very, very interesting and very, very nice chapter, and you get to know about your environment, about what's happening, right? Physics is very interesting, right? If you get to relate things, right, you are very inquisitive and curious to know what is happening, how it is happening, then this chapter is the base, right? You must practice and you must understand the concept. And if you have any kind of doubt, don't think that your doubt is silly. Feel free to ask. These small doubts maybe can turn into some observation and discovery and things. So do ask, do think, do brainstorm, do come up with new questions, and take care. Bye bye. Meet you in the next chapter.